Okay, if you missed class the other day, here's what you missed. Since it was homecoming, I sped things up a little bit. But I reviewed just a little bit to make sure that people remember how to solve absolute value equations. And then I went right into solving absolute value inequalities. Now I'm going to confuse you a little bit at first. There's a shortcut that after we do a few of these, I'm hoping that you realize what it is. So hopefully I won't get going too fast on this video. Write down some notes. Your assignment is a worksheet. So it's called Worksheet Day 6. So after you watch the video, this will be the assignment. So hang on and we'll show you what we got. Here's where I started with. The absolute value of 3x is less than 15. What does that mean? I'm wanting you to find some number, multiply it by 3. And once you've done that, you're less than 15 units from 0. And I'm hoping, without showing you much math of it, you can kind of just imagine some things real fast. Think about your number line. Well, 3 times what number would put me exactly 15 units away? Well, 3 times 5 puts me at 15 units away to the right. Well, how about 3 times some number puts me 15 units to the left? Well, that number happens to be negative 5. Last time those would have been our answers, but today I added in an inequality. So here's what I'm going to do now. We will speed this process up as we go, but I'm going to try to find some numbers that work. So some numbers more than 5, like 6, I'm going to ask myself, if I plug a 6 right there, 3 times 6 is 18. Is 18 less than 15? So no. These numbers won't put me closer. I'm going to try a number like to the left of 5, like 4. 3 times 4 is 12. Is 12 less than 15? Yes. So far, I know that I could use a 4. I could use a 3. I could use a 2, a 1, a 0, a negative 1, a negative 2, a negative 3, a negative 4. I can't use negative 6 because 3 times negative 6 is negative 18. The absolute value of negative 18 is positive 18, which is not less than 15. So here's my answer to this problem. That's my answer to that problem. Any number between negative 5 and 5. To review interval notation and writing things as an inequality, in interval notation, it's going to look like this. Parenthesis, because I'm not including it, negative 5, comma 5. In interval notation, it's going to look like this. Negative 5 is less than x, which is less than 5. Remember, we have to read from the variable. X is greater than 5 and less than 5. So that's my first example. Here's my next one. Once again, I'm just trying to do this in our head. The absolute value of 5x is greater than or equal to 20. So I want numbers such that when you multiply them by 5, you're going to be more than 20 units away from 0. Well, 5 times 4 puts me exactly 20 units away. So I know that one of my answers is 4. And hopefully you're thinking, well, my other answer is going to be negative 4. Why? Because 5 times negative 4 is negative 20, but the absolute value is 20. And since it's a greater than or equal to, I know these dots are going to be colored in. Now I just got to decide which kind of numbers will work. Remember, I'm trying to be more than 20 units away from 0. So I might look at a 5. 5 times 5 is 25. 25 is greater than 20, so I could use a 5 and a 6 and a 7 and so forth. So I know I can use that set of numbers. I'm going to see if I could use numbers in between negative 4 and 4. So I might look at 3. If I look at 3, though, 5 times 3 is 15. 15 is not greater than 20, so I can't use numbers in here. You could try a few if you wanted. I'm going to look at maybe numbers out here, like I might look at negative 5. I'm going to see if I can use negative 5. 5 times negative 5 is negative 25. But the absolute value of negative 25 is positive 25, which is greater than 20. So there's my solution set. In interval notation, it looks like this. Negative infinity to negative 4, bracket on negative 4 since it's greater than or equal to, parenthesis on there, the word 4, bracket 4 to infinity. As an inequality, it simply looks like this. X is less than or equal to negative 4, or X is greater than or equal to 4. And then we got it done. Here's my next example. I got 5 of them, and then I'm hoping that you can put some things together. The absolute value of x plus 2 is greater than or equal to 13. What does it mean? I want you to find some number such that when you add 2 to it, you're more than 13 units away from 0. I'm going to take care of the obvious one first that you're already thinking. 11. Because 11 plus 2 is 13. And I know I can include 11. Let me see what other kind of numbers I can use. Let me see if I could use a 12. 12 plus 2 is 14. 14 is greater than 13, so I could use a 12, a 13, a 14. I can use any numbers over there. Let me see if I could use a 10. 10 plus 2 is 12. 12 is not greater than 13, so I can't use a 10. There's another number over here. This puts me 11 units to the right. I need some number plus 2 that'll put me 13 units to the left. Here's what I need, guys. I need some number plus 2 to put me 13 units to the left. So x plus 2 equal negative 13. I'm going to solve this. Minus 2 from both sides. X, my other number is negative 15. This is what we did 2 days ago. Remember that 2 days ago this was just an equal sign. X plus 2 equal 13. X plus 2 equal negative 13. I'm going to try negative 16 now. I'm going to see if it'll work. Negative 16 plus 2 is negative 14. But the absolute value of negative 14 is 14, which is greater than 13. So here's what this solution looks like. So I went x plus 2 equal 13, solved it. X plus 2 equal negative 13, solved it to get these two numbers. Now, in interval notation, just to keep practicing it, negative infinity to negative 15, bracket, parenthesis, or bracket 11 to infinity. As an inequality, that means we're using inequality symbols. X is less than or equal to negative 15, or x is greater than or equal to 11. Here's the graph of it. Here it is in interval notation. Here it is as an inequality. I've got 2 more that I'm hoping we put things together, and then I've got 3 or 4 to go over with you after that. So here goes again. I know it's getting harder, but hang with me. The absolute value of 3x minus 2 is greater than 13. Well, what's it mean? I want you to find some number, triple it, take 2 away from it, and be more than 13 units away from 0. In your head, you're probably finding the obvious answer, 5. If you're wondering how we got 5, one way, 3x minus 2 equal 13, add 2 and get 15, divide by 3 and get 5. I'm going to put an open dot on it because it's just greater than. I'm going to see what kind of numbers I can use now. So I might look at 6. If I look at a 6, 3 times 6 is 18. 18 minus 2 is 16. 16 is definitely greater than 13, so I could use a 6, a 7, an 8. So I can use this set of numbers. To get my other answer, though, I'm going to go 3x minus 2 equal negative 13. Notice, guys, I'm not paying a lot of attention to that yet. Let me add 2 to both sides to get negative 11. Let me divide both sides by 3, and I'm going to get x is negative 3 2/3. No ugly decimals. Remember, I don't want any ugly decimals. So if you got 0.66666, backtrack and get me the nice answer. Now, here's negative 3 2/3. I need to decide what kind of numbers will work now. So I might pick a number on either side of that. So I'm going to look at negative 4. 3 times negative 4 is negative 12. Negative 12 minus 2 is negative 14. The absolute value of that is 14, which is definitely greater than 13. So here's my answer. We'll practice writing in an interval notation again here in just a second. But I got one more that I'm hoping that you see a pattern because we need a shortcut because we can make these so much faster. Here's my last one. for a second. 5 times some number plus 7, I need that to be less than 22 units away from 0. You might be able to look at that and say, hey, Mr. Harris, the first number is 3, because 5 times 3 is 15. 15 plus 7 is 22. So here's what I did. 5x plus 7 is 22. Minus 7 from both sides and get 16. Divide both sides by 5. One of my answers is 3. I'm going to put a closed dot on there. Now I'm going to see what kind of numbers I can get. Like, let me toy with a 4. I'm going to see if I can use 4. 5 times 4 is 20, plus 7 is 27. 27 is not less than 22, so I can't use 4. Let me try 2. 5 times 2 is 10, plus 7 is 17. It's definitely less than 22, so I can use numbers in here for a little bit. Let me go get this other main number, though. So I'm going to go 5x plus 7 puts me 22 units to the left, so negative 22. Minus 7 from both sides and get negative 29. Divide both sides by 5, and since this comes out to be a nice decimal, you can use negative 5.8. So I'm putting negative 5.8 there. I know it's a closed dot because of the less than or equal to. I'm going to look at negative 6. 5 times negative 6 is negative 30. Negative 30 plus 7 is 23, which is not less than 22. So here's my answer. In interval notation, it looks like this, bracket, negative 5.8 comma 3, bracket. As an inequality, it looks like this. Negative 5.8 is less than or equal to x, which is less than or equal to 3. Guys, we will always have less than signs in there when we write it as an inequality if it looks like that. Now here's what I'm hoping that you noticed a little bit. Here's the 5 examples that I just did. And I've only got 4 more examples after you see this. But I'm hoping that you notice this, guys. Here's a less than, and here's a less than or equal to. Notice how the graph looked. The graph went between the two numbers every time. Notice that here's a greater than or equal to, a greater than or equal to, a greater than. Notice what the graph does. They go away because you're trying to get further and further away. So greater than is going to look like this. Less than is going to go between the numbers. Never, ever, never, ever will the graphs go like the same direction. In an absolute value, they will never, ever go the same way. So here comes I've got 4 examples. Pause the video if you need to write it down, but I'm just going to roll with it. But watch how I attack these. I'm going to skip through these 2 slides. Watch how I attack this now. The absolute value of 5x plus 4 is greater than 24. Here's the things that we know. Before I do any math, guys, I know I have 2 numbers because it's absolute value. I know since it's greater than, I'm going to have open dots. And since it's greater than, I know my arrows are going to go away. That's what I know so far, just by looking at the absolute value and the greater than sign. Now, here's how I want you to handle this. Ignore the inequality sign now. Flat out ignore it. Trust me, you've already taken care of the inequality with these arrows. The only thing I'm missing is the number that goes here and the number that goes here. So I'm now going to go 5x plus 4 equal 24, and 5x plus 4 equal negative 24. That'll get me my 2 numbers. Minus 4, divide by 5. It looks like one answer is going to be 4. On this one, let me subtract 4 and get negative 28. Divide both sides by 5 and get negative 5.6. So I'm going to put a 4 here. I'm going to put negative 5.6 there. Boom, there's the graph of it. There's the graph of it. As an inequality, it looks like this. As an inequality, x is less than negative 5.6 or x is greater than 4. In interval notation, it looks like this. Parenthesis, negative infinity to negative 5.6 or parenthesis 4 comma infinity. Okay? There's what I've got so far. I've got 3 more to go, so hang with me. I've got 4 times the absolute value of 2x plus 1 minus 7 is greater than or equal to 5. Things that we know, nothing yet. You might know something, but you might not. Here's why I say nothing yet. I need this to look like this. I need the absolute value of 2x plus 1 to be by itself first. Then I start knowing things. Just like when we solved equations, the absolute value's got to be by itself. So I'm going to add 7 first and get 12. And then I'm going to divide both sides by positive 4 and get greater than or equal to 3. So once again, guys, I added 7, got 12, then I divided by 4. Now, things that I know a lot now. I know I'm going to have 2 answers because it's absolute value. I know my dots are going to be closed. And since it's greater than or equal to, I know my arrows are going to look like this. So that's everything I know. I have now taken care of that dang inequality. The only thing I'm missing is the 2 numbers. That'll get me 3 units to the right and 3 units to the left. So at this step again, ignore that greater than or equal to sign and use an equal sign. So I'm going to go 2x plus 1 is 3. And I'm going to go 2x plus 1 is negative 3. I'm going to subtract 1, divide by 2, so one answer is going to be 1. I'm going to subtract 1 and get negative 4, divide by 2 and get negative 2. So 1 goes there, negative 2 goes there. In interval notation, it's going to be negative infinity to negative 2, bracket, or bracket 1 to infinity. As an inequality, and on your worksheet I need you to write them both, by the way, it's going to be x is less than or equal to negative 2, or x is greater than or equal to 1. We're down to 2 examples left. Here's my next to the last one. Once again, guys, things that we know, nothing yet. Nothing yet. Because the absolute value is not by itself. So I need you to get the absolute value of 4x minus 3 by itself. So I'm going to minus 11 and get 27. And then I'm going to divide by 3 and get 9. So I got less than or equal to 9. Now I know some things. I know there's 2 answers. I know it's less than or equal to. So close in the dots. It's less than, so I know my answer goes between those 2 numbers. At this point now, ignore the less than or equal to and then use an equal sign. Because all you need is the 2 answers. So 4x minus 3 equal 9. 4x minus 3 equal negative 9. I'm going to add 3 and get 12. Divide by 4 and get 3 as one answer. On this one, I'm going to add 3 and get negative 6. Divide both sides by 4, and I can use negative 1.5. I can use 3 over 2. I could use 1.5. Any of those will work for me, guys. So 3 here, negative 1.5 there. You'll like less than better because in interval notation, it just looks like this. Bracket, negative 1.5, comma, 3, bracket. Easier to write. As an inequality, it looks like this. Negative 1.5 is less than or equal to x, which is less than or equal to 3. So there's what I got so far. And here comes my last one. Things that we know yet, things that we think we know. We might think, as soon as you see this greater than sign, you might think this. But let me see if that's right. The absolute value is not by itself yet. So let's get it by itself. I'm going to subtract away 6 from both sides. So that gives me negative 20 over here. And then I'm going to divide by negative 2. Listen to those words I just said. Divide by negative 2. So I'm hoping you caught that. Since I'm dividing by negative, I got to flip this sign. It's no longer a greater than, it's now a less than. Negative 20 divided by negative 2 is positive 10. So the trick on that one, guys, I divided by negative 2, flip your sign, just like we've been doing. So now, here's the things that I know. Open dots, it's less than, so my arrow's going to come together like that. The only thing I'm missing now is my numbers, so 3 plus 2x is 10 units to the right. 3 plus 2x is 10 units to the left. I'm going to subtract away 3 and get 7. So one answer is 7 over 2, 3 and 1/2, 3.5, you pick it. On this one, I'm going to subtract away 3 and get negative 13. Divide both sides by 2 and get negative 6.5. So 3.5 goes here, negative 6.5 goes there. In interval notation, it looks like this, parentheses, negative 6.5 comma 3.5. As an inequality, negative 6.5 is less than x, which is less than 3.5. So there's what you missed last time, guys. Now remember, you have a worksheet now. It's called Worksheet Day 6. And then once you do that, solve it, give me the answer in interval notation and as an inequality. Good luck. Come in if you need any help after you watch the video.